Quick, graph y equals the opposite of the natural log of the quantity 1/2 x by hand 2 different ways. This is part of the family of functions series. You will need graph paper, or you can download this PDF and print it. Press pause as needed anytime during this video. First, we need to decide what the parent function is and its shape. Parent function is y equals the natural log of x, and its shape is this. Kind of looks like a easy chair dumping you out. We do need to pay attention to this vertical asymptote at the y-axis. Please recall that the natural log and e to the x are inverses of each other, which means we just interchange ordered the x and y coordinates. So identifying the parameters, these are values in the expression that affect the graph. There are 2 of them right here. And how do they affect the graph? Well, the 1/2 inside the parentheses, inside the function, is a factor in the argument. And we need to recall that that coefficient is inversely proportional to the horizontal dilation factor, which is the reciprocal of that coefficient. So in this case, we multiply each x value by the reciprocal of 1/2, which is 2. The opposite sign takes the opposite of each y value. Notice that the vertical asymptote is unaffected by these parameters. So we'll graph x equals 0, the y-axis, as our boundary line, our vertical asymptote. And the so-called origin is unaffected by these parameters. So we'll plot all points from the origin 0, 0. Now we're ready to do the natural log of x dance. Normally that's right 1 up 0, but we have these parameters that are affecting that. So we need to multiply each x value by 2 and take the opposite of each y value. So that will become right 2 up 0. So we'll plot that. Notice we also supply the powers of e that we need to know. The next step in the dance is right e up 1, but in this case it's going to be right 2e up or down 1 because of the opposite there. Right 2e down 1, and 2e is about 5.4. Next step is right e squared up 2, but it's going to become right 2e squared down 2, and doubling 7.4 is 14.8. Right e to the negative 1 down 1, doubling that will be 2 times e to the negative 1 up 1, which is about 0.81. And finally, right e to the negative 2 down 2 is our normal dance step, but it's going to be right 2e to the negative 2 up 2. 2e to the negative 2 is about 0.28. Connect the points using that asymptote as a boundary line there, and we can compare it to the parent function. You can see that it's been reflected and also kind of stretched out a little bit because of the 1/2. Using a table, before we do that, again, natural log and e to the x are inverses, and these are the powers of e that we need to know. Here's our table of 5 values that we usually use. The 1/2 inside the argument, multiply each x value by its reciprocal, which is in this case is 2. So 7.4 times 2 is 14.8. We're going to ask you to go ahead and finish those 4 values. Pause to do that. Resume when you're ready. So 2.7 doubled is 5.4, 2, 0.8, 0.28. Again, press pause anytime to get caught up. The other parameter is the opposite sign, which takes the opposite of y values. So when we take 2 and take the opposite, it becomes negative 2. And then we go ahead and plot 14.8 comma negative 2. We're going to ask you to finish these 4 values, plot the points, draw the graph. Resume when you're ready. So the opposite of 1 is negative 1, so 5.4 negative 1. Opposite of 0 is 0, so 2, 0, that's an x-intercept. Opposite of negative 1 is positive 1, so 0.8 up 1. And the opposite of negative 2 is positive 2, 0.28 up 2. Draw the asymptote. It appears that this is a boundary line, the y-axis, the line x equals 0, so we'll draw that asymptote. And we're ready to connect the points. And there's our graph there, and we will compare it to the parent function. Now you try one. Graph y equals 1 minus the natural log of the quantity 1/3 x. Use either method or both for the practice. Press pause to do this and resume when you're finished to check your answers. And here's our answer in green, and also I included a table.